In this video, we're going to look at doing some work on Desmos using something called sliders. So we're going to show how to create sliders in Desmos, and then we're going to show how to use these sliders to change the values of constants in function formulas and use them to help us understand how these functions work. Okay, so here we are on Desmos, and we're going to look at a function that is similar to the logistic models that we were using with populations, and we're going to look at what the graphs look like in general. So what do those look like? Well, we're going to simplify it a little bit. Our f of x is going to look like a divided by 1 plus b to the x. Back in the old days, we'd have a coefficient in front of that b to the x, but we're going to make it a little simpler this time to see what happens when we have two constants. The first thing you might notice is that nothing is being graphed. That's because Desmos does not recognize the a and b as actual numbers. We are going to make it recognize it by making them sliders. So you see down here, right around here, it says add slider. I can add both of those a and b to be sliders, but I'm going to do it one at a time just for funsies. So if I click on this a, that'll turn a into a slider. And notice down here it says a equals 1. What has happened is we've made a slider that helps us change the value of a starting at a equals 1. So we're going to, and again, notice nothing's in the graph yet. That's because it still doesn't know what to do with this b, but we're going to add a slider with b as well. And notice now that we get this nice pretty purple graph down here. And here we start off with a equals 1 and b equals 1. And of course, if you put a equals 1 and b equals 1, you end up with the function f of x equals 1/2. That's why we get a nice little constant down here. But by changing the values of a and b, we're going to get different graphs. So I'm going to keep a equal to 1 right now, and I'm going to change the value of b. And what I do is I go to this little blue dot here, and I'm going to move it. What the heck? I'll move it to the right. And look what happens when I move it to the right. It changes the shape of the graph, and when I move it to the left, also changes the shape of the graph in different ways, right? So that's interesting. And so here I'm just going to keep it, what the heck, I'll keep it here right now. Now I'll see what happens when I change the value of a. When a goes down, notice the graph flattens out, and as a gets bigger, the graph gets bigger. And if I want to make a negative, what the heck, it's worth a try. Notice that it just sort of flips and goes underneath the x-axis. So I'm going to make a positive. Negative's kind of freaking me out here. So I'm going to keep it here at a equals 4 for now, and see what happens as I change the value of b again for this value of a. Well, it looks like I get basically the same shape of graph as I got when a was equal to 1. It's just a little taller, and now that I'm noticing it, right around here it looks like I've got a horizontal asymptote at y equals 4, probably related to this a equals 4 over here. Let's see if I do an a equals 5 and it gives me a similar type of deal. Yeah, see over here? Now my asymptote is at a equals 5. So we get to recognize a bunch of interesting things about the graph. For one, this a seems to indicate where this horizontal asymptote is going to be. And actually that is whether the graph goes like this. And interesting. So at b equals 1, if it's less than 1, the graph is flipped over on this side. Our horizontal asymptote of a equals 5 is over on the right. And if b is bigger than 1, then our horizontal asymptote where y equals 5 is over here on this side. And notice on the other side from that, it seems like we have a horizontal asymptote on the x-axis, y equals 0. So there's something about b equal 1 that's sort of like a changing point where the nature of the graph kind of changes, which isn't surprising. At b equals 1, we get that constant, and we move to the left, move to the right, interesting things happen. So let's see. So we tried one where a is negative. Let's see what happens when b is negative, just for fun. And holy crap, there's a lot of weird things going down here. And it's kind of hard to see, but there's all these little dots. So something weird happens when b is negative. And if you look at the formula over here, this b to the x, taking a negative number to x can be really how shall I say, unstable, because we don't know how to handle certain values of x. For instance, what do I do if I have negative 5 to the, I don't know, to the 4.5 power? It's really weird. There are only certain values of x where this makes sense, and that's probably why we have these dots here. So rather than attempting the universe to explode or something like that. Let's keep b positive. It seems b being positive is the only one that makes sense here. And anyway, in any case, so making sliders is pretty easy. You just put in a formula where your constants are variables. You click on the variables that you want to be have sliders, and then you click on these little blue dots over here and move them back and forth to see how the different constants affect your function. So I've just shown you how I played around with this function. You're going to play around with polynomials to see how the different constants affect things, and we'll see what we can come up with. Well, now that you've seen me play around with sliders, now you get a chance to play around on sliders as well. You're going to be looking at the file called Exploring Polynomial Roots and Graphs.